Okay, now that we know how to graph a quadratic function, let's expand to graphing things of higher order, so just polynomials in general. Okay, so first thing that we can notice here is that if x equals 0, the only term that will count will be the end term. So y will be equal to 50, because this will become 0, 0, 0, and we'll be left with y equals 50. So it's really easy to find the y-intercept of a polynomial. X equals 0, y equals 50. Sorry, this is our y-intercept. But as x starts changing values, these in-between terms, or these other terms, start to be kind of significant. If x equals 1, then y is equal to 1 cubed, which is 1, minus 2 times 1, which is 2, plus 10 times 1, plus 50. So this end term's still really important, but now we've got 10 here, minus 2, plus 1. So, you know, there's some other stuff going on. But notice what happens as x gets larger and larger and larger. Now, our first term, because it's cubed, becomes 1,000, and then we have 2 times 100, plus 10 times 10, plus 50. So now the 50 is way less significant, and this front term here, being, think of it as maybe like $1,000, is kind of dominating. So when you have $1,000, 50, 100, and 200 are not as significant, but still significant. But let's let x grow even bigger. If we have x being 1,000, then x cubed is 1,000, 1,000, 1,000, which I believe is called a billion. 1,000, 1,000, 1,000, that's x cubed, minus 2 times 1,000, 1,000, 2 million, plus 10 times 1,000, 10,000, plus 50. Now, if I have $1 billion, 2 million is starting to look like small change, and 10,000 certainly fairly insignificant. $50, I probably tip that just because you held the door open for me. Okay, if we continue this process and make x equal to 1 million, then our front term here, by the time we cubed it, will be 1 million, million, million. And of course, the next term is still going to be squared, but it's just going to be 1 million, million, so it's going to be in this place right here. And then coming along after that will be 10 million, 1, 2, 3, 4, 5, 6, somewhere around here, 10 million, and then the 50 will be down here. So you can see that this is becoming even more significant. And that process continues as x gets larger and larger and larger. So we say x goes to infinity, y is approximately just equal to whatever the largest term is doing here, like that. Okay, so we look at a polynomial like this, and we can see the constant term tells us what happens if x is equal to 0, but the largest degree term gives us what's called our end behavior. And by end, I would think of end of the x-axis, because that is where the very, 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 very large values of x are. Similarly, at the other end of the x-axis, you also have numbers that are very, 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 very large in size.